2x equals 6. This is an example of a one-step equation with whole numbers. So to solve this, you would first divide 2 by 2 and 6 by 2, so you could isolate the x, which is the variable, so the 2's would cancel out, and because you divide one side by 2, you'd have to divide the other side by 2 to keep it equal. So 6 divided by 2 is 3, therefore x equals 3.
Two-thirds x equals 6. This is another example of a one-step equation, and so therefore the first thing that we need to do is isolate the variable, and this is our variable x, and so we would divide 2/3 x by 2/3, and this cancels each other out so that we can bring x down, and what we do to one side we have to do the other because math is in balance, so we would also divide 6 by 2/3, and whenever you're dividing a fraction, so 6 equals 6 over 1, because it is 6, and to divide, you would be dividing by 2/3, and dividing is the same thing as multiplying by the reciprocal, it's the opposite, so you would multiply, that would be over 2, so you would multiply 6, which equals 18, 6 times 1, and 1 times 2. 18 over 2, which when simplified, or divided by 2, equals 9 over 1, which equals 9. So, your answer is x equals 9. Done.
Plus 2 equals 6. This is a two-step equation. So what we would do is we would use SADMEG, which is pretty much the opposite of PEMDAS. So what we would do is we would draw this wall here to properly separate it. And what SADMEG really tells us to do is to subtract first. So we would subtract 2 from 2 and subtract 2 from 6, and which would of course get us so that would be 0 and that would be 4. And then since we did that, we would pretty much, after we do that, we would just treat the rest of the thing like a one-step equation, because that thus would be 2x equals 4. And so again, we would subtract, divide, my bad, from 2. So that would give us, so that would just cancel out the 2's. 2 from 4, because we have to do the same thing to both sides. And then, because 2x, so x would equal 2, because 4 divided by 2 equals 2. So x equals 2.
Okay, 2/3 times x plus 2 equals 6. So this is another example of a two-step equation, except this time we have a fraction instead of a whole number or a rational number. So to solve this problem, it's pretty much the same steps. You would use SADMEG and do the same steps, except when you get to the one-step equation, you would just solve with using fraction rules. So first we would use SADMEG, which is the opposite of PEMDAS, which tells us to subtract the 2. Actually, first, before that, we could even draw the wall, which separates our problem on both sides of the equal sign, so that we know what's what and what we have to do. And so first, we have to subtract the 2 from the positive 2 to cancel out. And what we do one side, we have to do the other. So 6 minus 2 would give us 4. And then it would be 2/3 x equals 4. And then you would just treat the rest of the problem as if it were a one-step equation. So you would divide 2/3 x by 2/3, which cancels each other out to isolate the variable, and then you would divide 4 by 2/3, so you would do 4 divided by 2/3, which then you would multiply that by the reciprocal, so it would be 4 times 3 over 2, which gives you 12 over 2, which gives you 6 over 1, which equals 6, so x equals 6.
3 times 2x plus 2 equals 36. And this is an example of a multi-step equation. So to solve this, first you would use distributive property, which is basically just distributing the outside number, in this case 3, to the 2x, or just both of the inside numbers, so you distribute the 3 to the 2x and the 2. And once you distribute it, that's pretty much just multiplying it. So 3 times 2x equals 6x, and 3 times 2 equals 6, so that's 6x plus 2 equals 36. That is what we have now. So I will draw the wall to remind myself that what I do on this side, I must do to the other side. So what I will do now is use SADMEG, which, as you remember from the previous video, is pretty much just the opposite of PEMDAS, which tells us to subtract first. So I will subtract 6 from 6, which gives us 0, then divide 6 from 6 here.
Subtracted from 36.
Yeah. And then I will subtract 6 from 36, which will give us 30. Then, because I divided here, I will divide 30 by 6. That's not how you divide, but whatever, which would give us 5. X equals 5.
Okay, 2 with 2x plus 3 in parentheses minus x plus 4 in parentheses equals 6. Okay, so this is a complex multi-step equation in which you have 2 groups of parentheses that you'll need to be distributing twice. And before you distribute, you can treat the negative or the subtraction sign in front of the group of x plus 4 as a -1, because really you'll be just multiplying or distributing the negative to both of the numbers inside the parentheses, and you'll do the same with the first group. So when you distribute the 2 to the 2, you get to the 2x, you get 4x. When you distribute the 2 to the 3, you get 6. And then when you distribute the -1 to the x, you'll get -x. And when you distribute the -1 to the 4, you would get -4. Equals 6. So when you have a lengthy problem like this, you will need to combine like terms in order to simplify the problem into a 2-step equation that you can solve using SADMEG. So since 4x and -x both have, it's really -1x, they both end with x, then you can combine them. So you will combine, and 4 combined with -1 gives you 3. That'll be 3x, and then you can combine 6 and -4, which when combined it gives you 2. So then you have a 2-step equation, which you can then treat like you would normally treat a 2-step equation. So you'll use SADMEG to, first you can draw the wall to separate the problem on both sides of the equal sign, and then you'll subtract 2 to cancel out the 2, and what you do to one side you have to do to the other. So then 6 minus 2 gives you 4, so then you're left with the problem is 3x equals 4. And then you'll do the inverse operation to isolate the variable. So you will divide 3x by 3, which isolates the variable, and then 4 divided by 3, which gives you, when divided, 1.34. which repeats forever. So x equals 1.3 with a bar notation.